Alright, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
Waalaikumsalam
warahmatullahi
warahmatullahi
wabarakatuh.
wabarakatuh.
Good afternoon, everyone.
Afternoon, sir.
Afternoon, sir.
Okay, are you fine?
Fine.
Good. Are you ready to study?
Yes, sir.
Good. So before we start our lesson today, let's pray. Pray begins. Okay, finish. All right, guys. So please fill in the attendance before we start. So today we are going to continue our lesson about the periodic table. As we know that last lesson we learned about the history of the periodic tables. Today we are going to see a little bit about the what we can say interesting thing in the periodic table, because when you know something, you can predict some of the thing. If you know something, then you can predict some of the thing. Like the Mendeleev, as we know that last lesson, Mendeleev predict the existence of the element which has not been found at that time. And what he predict is pretty similar with the properties of the element that found later on. So knowing something, you can predict the other things. Yeah, by knowing something, you can predict the other things. Like for example, you can forecast what the weather. If it is now there is no no sun, no sunlight, because too many clouds, then we can predict that there will be rain, right? So something like that we can predict if we know something. Yeah, some properties of some characteristic we know, then you can predict some of the thing. So this is the same. Now in the predict table, you can know many things and you can predict also many things by knowing the predict tables. Yeah, like Mendeleev did. He know the properties of the element and he grouped the element and he think that there must be another element here that will have properties like this and like that. So he can predict. Now here we are going to learn today. First, we know some of the thing. We know about the quantum numbers before. By using the quantum numbers, we are going to predict the a position or the place of the element in the periodic table. Yeah, by knowing the electronic configuration, and then we know the quantum numbers. By using those concepts, we are going to find out the position or the place of each element in the periodic table without knowing or without looking at the periodic table. What is the advantages for you if you know that this one? The advantage is if you know already the place of the element in the periodic table, then you can predict also the properties. And for that one is very important. In chemistry, properties of the element is very important. If you know the properties, then you can predict many things related to the reaction later on. Okay, let's start with the lesson day. Okay, so it's about the prediction, guys. Sorry, why is still written like this? Sorry, the internet is getting slower here in my home. Internet is getting slower. I couldn't see the. Oh my God! I have to download first. Sorry, this one is not good. It's already been. Wait a minute, yeah. I have to download the slides. Okay, let's see. Something happened with the slide, so I have to find a new one. Okay, it's coming now. I hope it is good. Okay, so while we are waiting for the slides, so let's do some review about the lesson. Okay, one student please, Dapa Rajendra, can you make a little bit some review about what we learned last lesson?
Evolution of periodic table.
Sorry, I couldn't hear you.
Evolution of periodic table.
Okay, how many scientists that we explained last lesson?
3,
Three?
I think.
2? Who are them?
Mendeleev and the modern one Moseley.
Before Mendeleev? Do you remember?
Mendeleev and Moseley.
Newlands.
Newlands, and then before Newlands?
Dubriner.
Dobereiner?
Yeah.
Okay. What is special for Dobereiner?
Triads apa itu?
Triad system.
Okay, Dobereiner is talking about triad, good. How about the Newlands? Talking about what?
Octave.
Newland is talking about octave, very good. And then Mendeleev is talking about what?
Group, I think.
Yes.
Periodic table.
Mendeleev is talking about periodic table. Okay.
Yes.
And then what's the difference between Mendeleev and the modern periodic table, guys?
Mendeleev is sorting
Mendeleev is the atomic mass and the modern one atomic number.
Mass.
Okay. Mendeleev by atomic mass. How about the modern periodic table?
By atomic number.
Is atomic number. Good. So who proposed the atomic using atomic number?
Moseley.
Henry Moseley, isn't it?
Yes, sir.
Okay. What is interesting in Dobereiner triad? You say about Dobereiner triad, right? What is what interesting about Dobereiner triad? He said that if you order the element from the lowest atomic mass to the highest atomic mass, the atomic mass for the middle element will be the average of the atomic mass of the first and the third element, isn't it?
Yes.
Yeah. So those are about the history, guys. Now, today we are going to learn a little bit about that periodic table, yeah, not the history again. We are going to learn about the periodic table in detail today, and how to find the periods and the groups of the element in the periodic table. This is what we are going to learn today. Now, this is our modern periodic table, guys, the one that we use today. Okay, as you can see here now, the table is like this. Somehow have 4 different groups actually here. Sorry. So it's like have 4 different groups. Okay, let me show you what I mean for different groups. So this is the first group here. And we have the second group here. It's like a castle, right? Castle with two pillar in the left and the right. And in the middle here we have another group. This is in the middle. And under the main table, we have another table here under the main table. So mostly we have 4 different, let's say, groups of table here. So we are going to see what are those, and we're going to find what is the important for those 4 different groups of element in the table. Okay. First, before we came to that one, first we have to know that when we are learning about the predict table, there are 2 things that you have to know, which is important. 2 terminology that we use in the predict table. The first one we call as a groups, and the second one we call as a periods. Okay. What is groups? Group is from top to bottom, guys. So when we're talking from top to bottom like this in one columns, it is called as a groups. So groups in Excel, it is like columns. It is like columns from top to bottom. This is the first column, second column, and so on. Periods is from left to right. So from left to right, for example, here is one period. So when we're talking about the Excel, period is like a row. So it is columns and rows. Columns in predict table we call as a groups. Rows in predict table we call as a periods. Okay? Is it clear?
Clear.
Okay. Now let's talking about the groups, guys. What does it mean, the groups? The group is, I told before, it is columns. So for example, I have a main table here, predict table. This consists of some of the groups here. Okay, so this is one group here, 2 second group, and 3rd group, 4th group, 5th group, 6th group, 7th group, and 8th group. And we have 2 pillars, I told you, in the left and the right. So we can number this pillar from 1 to 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, we're not talking about the one which is in the middle here. Later we are going to talk about this, but we talk now the one which is in the left and in the right side of the table. Okay, so we have 8 group here, and actually the number of the group 1, 2, 3, 4, 5 is defined by the number of valence electron, guys. This one. What is valence electron? Valence electron is the electron in the last shell. Valence electron is the electrons in the last shell, guys. You know shell, right? We learned about this. So if we have the electrons in the last shell, we call that electron as a valence electron. And the element in one groups, they will have the same number of valence electron. Okay? The elements in one groups, they will have the same valence electron. For example, here, if I have 1A groups, so all of the element here in 1A will have 1 valence electron. 2A, 2 valence electron. 3A, 3, 4, 4, 5, 5, and so on until 8. If it's 8A, then there will be 8 valence electron, except for the first HA group. For the first HA group element, which is helium here, helium do not have H electron, but it's only 2. But the others element under HA group, all of them will have H electron. Okay, is it clear? Okay, and then what else? In the same groups, if the elements are in the same group, it is very important properties here. They will have the same chemical, not the same, sorry. I always say the same, but actually it's not the same, it is similar. Okay? The element in the same groups, they will have similar is not the same, yeah, similar chemical and physical properties. So for example, this element here, they are in the same group, 1A groups, then they will have similar chemical and physical properties, guys. This one is also the same, and this one also the same, and so on. All of them, the element in the same groups, they will have similar chemical and physical properties. Okay? And for the element here, the one which is in the left and the right of the table, we will have the name. Some of them are very familiar that you have to know by heart. For example, for 1A group, the one which is in the left, the most left, yeah, the left one, here called as an alkali metals groups. As you can see here, the name is alkali metals group. The second, beside that alkali metal, we will have alkali earth metals group. Alkali earth metals group. For group 3, 4, 5, 6, don't worry about this name. This name is not very important. Yeah, you don't have to know by heart for this name. This is the name that used in some of the books, but in Indonesian, generally they are not using this. So don't worry about the name for number 3, 4, 5, and 6. Yeah, you don't have to know that's not the name. Just you know that 3A group, 4A group, 5A group, and 6A group. But for 7, it is also important now. 7 is called as halogens. Yeah. So halogen is used in all of the world. So you have to know this name. If it's 7A, sometimes it's called as a halogens groups. And for 8A, it is called as a noble gases groups. Yeah. So we have 4 name of group that you have to know by heart. The first one is 1A is alkali metals, 2A alkali earth metals, 7A as a halogens, and 8A as a noble gases. So we have these 4 groups that have a famous name. Do you have any question?
No.
No? Can we move? Yes. Okay. Now, sorry, this is not goal. Yeah, it must be groups. Goal is like playing football. So sorry about this. This is not group. It's typo here. It's not goals. It must be group here. Yeah, it must be groups. We are still talking about the groups. We have 2 main groups, and it is called as a group A and group B. Okay, group A and group B. Group A is the main groups. Group A is the main group. Which one is group A? We know already. Group A is the one which is on the left of the table and the one which is on the right side of the table. So the one which is in the pillar of the castle, it is called as the A groups. That's why it is naming is 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A. Okay. How about B group? Which one is B group? B group is the one which is in the middle here, in the middle of the castle. It's called as a B group. And B group, the name is transition metals groups. Okay. The name for this one is transition metal groups. Transition metals group. Okay, the one which is in the middle, the color What color is purple? The purple color of the table here is actually the B groups. Okay, the blue one is A group, the yellow one is A groups, and the purple one here is B groups. How about the yellow one here, guys? What is this yellow groups? This yellow group is actually, it is belong to the B group, belong to the purple group. Actually, the first row here, it is the element that is located in this lactanide table, like lactanide block. Here we call it as a lactanide block. Yeah, the name of this one is lactanide block. Lactanide, the first row here. So lactanide is in here, in this block actually. So this block is a special group block. It is not only containing one element, but this block is containing more than one element. That's why it is opened up by one more row under the main table. It's called the lactanides rows. Yeah. The same thing for the second row. The second row is actually belong to this block. This block is called as an actinide, yeah, and this actinide is this block under lactanide block. So this is the same. Actinide also not only have one element in one block, but actually there are more than one element in the blocks of actinide. So that's why it is opened up in the below table as one row in below tables. So actually this yellow table is inside this purple table under the block of lactanide and actinide, guys. Yeah, actually we have only one table, but because in lactanide and actinide is more than one, element there, so we have to open the lactanide and actinide by using new rows. Okay, is it clear? Okay, now, how about the number of groups? How many groups we have? For HA group is easy. HA group is only have 8 group. Yeah, 1A is already known here. 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A group. So we have 8A groups. Totally there are 8 groups for A. For B, actually, when you look at the column, when you calculate the column, it is more than 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Actually, there are 10 columns here in B groups. But when you are giving the name, it is not 10 names. It is only 8 names. Yeah, it's starting from 3B here. As you can see here, starting from 3B, not 1B. Remember, it will start with 3. 3, 4, 5, 6, 7, 8. But as you can see here, there is something interesting here. After the HB group, we have another HB and another HB. So HB totally will have 3 columns. 3 columns of HB. Yeah. 3 columns of HB. So that 3 column is what accepted as HB groups. Not another 9 group or 10 group. No, HB group, HB group, HB group. We have 3 HB group, guys. And after the HB group, then we will have 1A, 1B group, and 2B groups. So totally, although we have 10 columns, but actually we have only 8B group, not 10. Is it clear? Can we move? Okay, good. Now, how about the periods? Periods is called as a rows. Yeah, the rows in the periodic table is called as a periods. So totally we have 8 rows already. 1, 2, 3, 4, 5, 6, 7 rows. Yeah, 7 rows. As you see now, lactanide and actinide is inside this. So it is not calculated as rows. So we have only 8 rows. So 8 row means we have 8 periods. Period 1, it is the first row, second, third, fourth, fifth, sixth, seventh, and so on. We have 7 periods. And this periods is showing you the cell numbers, the number of shell, guys. Yeah. If we have 1 shell numbers, if we have only 1 shell, then period is only 1. If we have 2 shell, then period 2. If we have 3 shell, then the period will be 3. Okay. So the period is depends on the number of shell. If 1 shell, 1 period, 2 shell, 2 period, 3 shell, 3rd period, 4 shell, 4th period, and so on. Is it clear? Okay.
Yes.
Now this is the most what we can say menyenangkan, the one which is very enjoyable thing here. We are going to predict the position of each element in the predict table, guys. How we can predict the position of each element in the predict table? We can use the electronic configuration, guys. There are some of the things here. I just want to read it, and after that I'm going to explain by doing an example, guys. This is easier to explain by doing example. Here are actually the rules for knowing the periods and the groups of each element in the predict table without looking at the predict table. You will see that it will be very enjoyable for you. The first one, the biggest principal quantum number or cell number of any atom shows you the periods. As we know that principal quantum numbers, yeah, principal quantum number is denoted by n, right? And it's showing you the cell number, isn't it? And we know that from the previous cell number is showing you the period. So if you know the principal quantum number, you will know how many shell number. And if you know how many shell number, you know in which periods is the element in the periodic table. So this is the first one. The second one, the total number of electrons in the highest energy cell. Actually, the electron in the highest energy cell is called as the, what we call that one? It is called as a valence electron. Actually, yeah, the total number of valence electron or the electron in the highest energy cell give you the group number. So if you want to find the group number, just calculate how many valence electron in the atoms or in the elements. If you know how many valence electron, then you will know the group number, guys. It's very easy. After you know the period, you know the group, now you are going to decide whether it is A group or B group. It is very easy also. If the electronic configuration is ending with S or P, then it is A group. If it's ending with D and F, then it is B group. It's easy to remember. If S and P is A group, if D and F, it is B groups. Okay, now let's make a little bit clear about this by doing the example, guys. Now, for example, determine the period and the group of the following atom in the predict tables. We are going to predict the position of each element here in the predict table without looking at the predict table. So what should we do to predict the position of this element in the predict table? We're going to write down the
atomic number.
Electronic configuration first. Now, lithium 3, so it is 1s2, 2s1. So, how do we know the period of this one? Period showing you the number of shell. How many shell we have here? Shell 1 and shell 2. So quantum number is 2, right? 2. So period will be period number 2. Second period. So the place of lithium will be in the second periods. How about the groups?
And with S,
One
so
A.
group B.
The group is the electron in the
Group
last
A.
shell, right? Last shell is shell number 2 here. This is the last shell. How many electrons in the last shell? 1 electron.
One on
So it is 1. It is A or B?
A.
It is ending with
A for
S, so it is must be A groups. So the period of the lithium is the second period and group 1A groups in the periodic table. Very easy, right? Let's do for the calcium. Calcium 20. How I can write the electronic configuration? It is argon.
1s2.
1s2, 2s2, 2p6.
Argon 4s2, isn't it?
Oh yeah.
You know how to write it simply. Please make it simple. So it's saving your time to write down the electronic configuration. Now, let's analyze the period. What is the period here?
4.
Period is 4. Yeah, because principal quantum number is 4. The groups, it is how many electron in the last shell? 2 electron. So it is A group. It's also A because ending with the S. Okay. Silicon 14. It is neon 3s2 3p2, isn't it? Okay. Period
3.
period 3 because we have here 3 shell. In the 3 shell we have 3s and s and p orbital. Groups
2A.
2a or 4a. Remember, design to know the group's number, you have to find the valence electron. What is valence electron? Valence electron is the electron in the last shell, right? Now here, 3s is also in the last shell. 3p is also in the last shell. Both of them are in the last shell. So if it is ending with P, guys, you have to add the number of electron in S and in P to know the group number. So not only calculating the one which is in the P, because we have also S in the shell number 3. So that's why totally the valence electron will be 4. So that's why it is in 4A groups, guys. Okay. So if it is ending with P, you have to add the number of electron in S and in the P in the same shell. Then that's electrons, the total electron will be the valence electron. And that's will show you the number of groups in the periodic table. Is it clear?
Yes.
Okay, now the last one, bromine. Bromine, it is argon still.
Yes.
4s2, 3d10,
3d10.
30, 5 more. 4p5, isn't it?
Yes.
Okay, good. Period?
4.
The highest shell is 4, okay. The last shell or the highest quantum number is 4. So period is 4 groups.
5d.
Now, maybe you will think that it's only 5, but remember, we have also S in the shell number 4. In shell number 4, not only P, we have also S. So 2 plus 5. You have to add the number of electron in S and in the P in the same cell. So it is
7.
Yes, it must be 7A, guys. Is it clear?
Yes.
Any question up to here? No? Good. Can we move? Okay.
Yes, yes.
So this is the answer, guys. Okay, next question. So this is the last question for today. We have only 4 minutes. Now the question in here, what is the number of electron of an element that is in third period and 5a groups? In the third period and 5a groups, the question is how many electrons of this element? Third period and 5a. How to solve this one? We should predict what is the electronic configuration of this element. First of all, it is third period. Yeah, third period, it's mean that it will have how many shell?
3.
3.
3. So let's write the electronic configuration. 1s, 2s, 2p, 3s. Now it is shell number 3. Is it finished in here?
Maybe no.
Probably no, because it is 5a group. What does it mean 5a groups? How many valence electron? 5 valence electron will be 5. So if I have 3s only, can we have 5 electron in 3s?
No.
No.
So you have to have another electron in p, right? So 1s, 2s, 2p, 3s, 3p.
3 P's.
So in the third period, it's also the same period. Now we can add now. If I have 3s, 3s must be fulfilled first. 2 electron here. Then to have valence electron 5, how many electron must be in p?
3.
3.
3. So this is our electronic configuration, guys. Let me put all the electron here. 2 for here, 2 for here, 6 for here. So totally, how many electron we have?
15.
15 electrons. So if I have 15 electrons, then this element will be in the third period and the groups will be 5a. Okay, guys, clear?
Clear.
Okay, so this is the last thing that I want to explain today. That's enough for today. Do you have any question? No? Okay, for your exercises, you can continue exercise in page 66. Latihan 2.6, we did number 1 until number 10. You can continue number 11, number 15, but you don't have to collect it to me, okay? Just you will do by yourself, and I hope you will do that. If you have any question, then you can ask to me privately. You can ask to me privately, and I'm trying to answer your question, but do not collect all your answer to my WhatsApp, okay? Yes, you will do, but if you have any question, you can ask. Don't send your answer to me, all of them. Just if you cannot do it, then you can ask me. We will have post-test after this, and that's enough for today. See you next lesson. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Warahmatullahi wabarakatuh.